Hello everyone. So today we are solving another question of JEE Advanced 2020. This is from the topic of rotational motion. And so let's read the first question first. So they are given a small roller of diameter 20 centimeter and has a axle of diameter 10 centimeter. It is on a horizontal floor and a meter scale is positioned horizontally on its axle with 1 inch on the scale and top of the scale. The scale is now pushed slowly on the axle so that it moves without slipping. One thing which you should always mark that wherever it is mentioned moves without slipping or pure rolling or something like that, you should first mark all those points in the question on the axle and the roller starts rolling without slipping. After the rollers has moved 50 centimeter, the position of the scale will look like. Okay, so we are given the speed of this roller. So we have to tell the position of our scale, which is being pushed on the axle of our roller. So let's first imagine how the scenario is working. So let's suppose this is our axle and this will be our capital R or of our roller. Look like something like this. Now, if we put our scale here, okay, so what will be the net speed of our scale? Okay, net speed of our scale will be if given there is a pure rolling motion happening. So when pure rolling motion will happen, let's suppose if this part is also moving with center of mass, like it is given that our uh, center of our roller is moving with velocity vcm, let's suppose. So the pure rolling condition will only happen when it is moving with omega. So vcm is equal to omega capital R, that is the outer radius. So this is the condition for the pure rolling here. And at any point, if you want to measure the actual speed, so what you have to do, if suppose this point we have to measure, so it will be omega R will acting in this direction and vcm will be acting in the, and the resultant of this will give you the actual speed of that point. But for some parts like this, which is at the perpendicular, so it will be vcm. Vcm is acting in this direction. Also, the omega r is acting in this direction. Omega r, I mean the small r, which is the distance from the center. So hence, what is the net speed of our scale? Speed of scale is equal to v plus omega r. Okay, and v is nothing but equal to omega capital R. And now given for us that the center is moving with velocity vcm, and after some time t, v into t, it is nothing but equal to 50 centimeter. So at this time t, what will be our position of our scale? So what we have to do, multiply this t with our speed of scale to get the position of our scale. Okay, so let's find omega. Omega is nothing but v by r. Okay, omega is v by r and t is 50 by v. So what we have to do here, let's write distance for scale. It is equal to v plus omega r into t, that is 50 by v. Now if we put omega, v plus v by capital R into small r into 50 by v, cancelling v here, we will get 1 plus r by r. That is, what is r by r? R is 10 and capital R is 20. So it will be equal to half into 50. 3 by 2 times 50, that is 75 centimeter. As the position moved by our scale is equal to 75 centimeter, and our option B is correct here. Let me write the answer. That is option B. Thank you.